We can use the periodic table to predict which charges or ions atoms can form based on where they are in the periodic table. Remember, elements in the same family have the same valence electron configuration, except one n level apart, so they give up or gain the same amount of electrons and therefore have analogous behavior. Group 1 has a valence electron configuration of ns1, and therefore that n orbital loses one electron to have a charge of +1. Group 2 wants to lose 2 electrons to become +2. If we hop over to group 13, which is 3 valence electrons, ns2 and p1, these atoms will lose 3 electrons to become 3+. Now, group 14, the carbon family, is ns2 and p2, so it has 4 valence electrons. These atoms can either gain or lose 4 electrons, but we're generally not going to see the atoms in this group form cations or anions as individual atoms. As we go from the nitrogens in group 15 to the halogens in group 17, we have 5, 6, and 7 valence electrons, and so we'll see these atoms form -3, -2, and -1 anions when they go for that ns2, np6 valence electron configuration. And finally, the noble gases have 8 valence electrons at ns2, np6, and so they are not reactive. Now, for transition metals, groups 3 to 12 in the middle, things get hazy. These elements have a configuration of ns2, n-1d something. So most of these elements can lose those 2 s electrons to have a positive charge of +2, but these atoms can also play with their d orbitals. However, we can't predict from the table alone how these atoms will act, and that'll affect how we write them in different molecules. Next, let's learn how to name these different ions. In the previous video, we learned that non-metal atoms can form ions with charges dictated by their electron configuration or group in the periodic table. These non-metal anions get their name from the first syllable of their name plus -ide. For instance, F-, a fluorine 1- anion, becomes fluor plus -ide or fluoride. O2-, oxygen 2- anion, becomes ox plus -ide or oxide. Why don't you pause the video and work through the rest of these, and I will post the solutions in the PDF key. We also learned that metals tend to lose electrons to become positively charged cations. While we can predict the charges for groups 1 and 2, we cannot predict for transition metals. So for metal ions, we don't change the name at all. For instance, calcium 2+ is simply calcium. However, if we look at a transition metal, we can't predict the charge. So we write the charge in Roman numerals after the name. For instance, iron 3+ would be iron, open parentheses, Roman numeral 3, close parentheses. Why don't you take a minute to work through these cations, and I will put up the answers in the key. The last type of ion you've actually just seen this week. These are polyatomic ions, or clusters of non-metallic elements that get an overall charge by sharing electrons through covalent bonds. You'll need to memorize the formulas and charges of the polyatomic ions.